right, so let's talk about intelligent document processing. So before we jump into slides, has anyone used um, Databricks to do intelligent document processing? How experienced are we with the capability? All right, so everybody's gonna be learning today. That's awesome. Um, so why intelligent document processing is um, so important is because roughly about 80% of organizations, large organizations, about 80% of their data is unstructured. So when you look at kind of the total volume of data, PDFs, scanned forms, contracts, emails, right? They kind of all fit in that category of unstructured data. And unlike structured or relational data, it's a little harder, or traditionally it has been a little harder to get kind of value out of that data. You've had to walk through several steps to extract the data, do text analysis or intelligent document processing to really get to the state of being able to use that data effectively within your business. Um, so today we'll kind of talk about intelligent document processing. We'll talk a little bit about, like older techniques that have been explored in this to solve this problem. Then we'll kind of break down what intelligent document processing is, um, and then we'll look at a couple examples, a couple demos that kind of step through what intelligent document processing could look like in the field. And then we'll open it up for any questions. All right, so let's kind of take one step back and like look at like what is it exactly. So IDP, also known as intelligent document processing, is essentially the practice of extracting structured data um, and turning it into usable data um, that can be used for analytics, for BI, for AI, right? Really, that's kind of the critical step of extracting the data from its raw um, presence, whether it's in a PDF, email, right? To be able to use it um, downstream. So in practice, these pipelines typically contain multiple steps, and ultimately they turn raw documents into structured fields, so into tables, you could say, right? That could be used by Power BI or Databricks, like other AI systems downstream. So it uses a multiple techniques, so it's got multiple steps to handle different types of data. So sometimes we deal with highly structured data. An example of that would be well, highly structured data would be like relational data, ERP data, healthcare data in a database, transactional database system. Semi-structured data would be like, JSON, XML, um, uh, like telemetry payloads. Unstructured data, this is your PDFs, this is your emails, and I would say primarily that's kind of the category that gets referenced a lot with intelligent document processing because that's kind of the untapped potential. And IDP really solves that. How do we get value from unstructured data? So like I mentioned in the intro, enterprise organizations have a plethora of unstructured data. Um, I've seen, up to 80% unstructured data in the form of emails, PDFs, scan forms, contracts, reports. And you look at these like scanned forms, these are sometimes like humans writing in their handwriting, filling out these forms that aren't like programmatic or typed, right? It's just human text, and then they're scanned in and sent in. So that presents some complications in terms of extracting the data and making, and determining, legibly what are they writing, right? A cursive A can look like an alpha symbol, for instance, right? Um, and then so when you look at unstructured data, there's a lot of costs associated with processing this data, and specifically a lot of operational costs. So if you look at labor, for instance, this has been a challenging problem to tackle for a decade or so. I look back at some of my experiences, probably my first time tackling a document processing problem was probably around like 9 or 10 years ago, trying to extract valuable data from government contracts. So we basically had to parse the document and do a technique called like boxing to strip out words in that document. It was very, very painful, as you can imagine, 9, 10 years ago. As technology has improved, we have some more advanced methods to make that easier, to make the labor costs lower, to improve latency and reduce the error-prone nature associated with processing documents, unstructured documents. So without IDP, really you're kind of limited to your relational database systems that you're commonly familiar with, right? Databases, ERPs, data within BI tools traditionally. So when you look at some of the legacy approaches, there's a few of them, right? So I mentioned that fixed coordinate approach where you're kind of like setting the boxes, the X and Y coordinates, and positioning it on a page to extract data. That is pretty error prone, right? And assumes each document is laid out identically, which typically is a, let's say, a short-sighted assumption. It's not typically in practice that you see that. You can use regular expressions to extract fields with text patterns, and then you can use something that is called OCR and heuristics. So these convert scanned images to text and apply rule-based logic to solve intelligent document processing. What is cool is once you kind of get past the extract phase, you can start doing analytics on the data. So is anyone familiar with like text analytics? Like using like the bag of words technique to determine like if two documents are similar. This isn't a presentation on textual analysis, but there's a lot of cool techniques you can start doing once you have the actual data in a format, extracted into a usable format. All right. So what's new? What's allowing us today to do this better, cheaper, faster than maybe a decade ago? So you're probably familiar with these large language models. They give us basically reasoning over unstructured text instead of rigid pattern matching. So instead of doing the regex or the fixed coordinate processing, we can use a reg that lets us ground that reasoning in the actual document instead of hoping the model remembers something relevant. like the XY coordinates in a document. So kind of what's new is a combination of three components: LLMs, RAG, which is retrieval augmented. Someone help me out here. What's the G? What was that? Yeah, I think that's right. Let me look it up. Just want to fact check myself here on the spot. Retrieval augmented generation. Yep. Okay. And then obviously your cloud scale compute, right? Being able to do, you kind of need, you know, large data centers to do this type of computation. So when you look at intelligent document processing, I'm gonna kind of go through this slide twice. I'm gonna go through it kind of broadly. So at a high level, every document kind of moves through these 6 stages. It's ingested, it's classified by type, then it's parsed into raw text, and then it goes through a process of chunking and embedding for retrieval, and then we retrieve and extract the specific fields we need. So I'm going to spend the next several slides going through each stage step by step. So this is kind of, the broad workflow at a high level. And the next, probably 6 slides here, we'll go through each one of these steps. So I'll kind of pause here for a moment. We can step through these 6 steps again. So you can ingest the data, multiple data sources, or a common data shape. Then it goes through a classification step for categorization and routing. Then we parse the text, so using rule-based text extraction. And then we go through a phase called chunking and embedding. And there's various chunking strategies that we'll talk about. This is where kind of the RAG comes into play here. And then the next step is retrieval. So then you're looking at basically a per field context and metadata around the unstructured data. And then the last step is the extraction phase. All right. So classification, this is kind of the first step in the 6-step process. The first is routing. So this handles multiple classes, essentially skips or flags irrelevant items. For instance, those, a's, words like that are often skipped. They're in a common dictionary that's skipped. Routing also enables config-driven pipelines. It's important. So config-driven pipelines is important. So the solution that you build is scalable. So it doesn't just work on one document. It works on a representative set of documents. Like, you don't want to design a solution that just works on one specific document. That's not as effective as having a config-driven approach that can process similar documents and not just the same document. There's types of classifiers. There's rule-based, there's traditional ML, and then there's LLMs, so your large language models. So here we kind of talk a little bit about why context matters for extraction accuracy. So extraction accuracy depends on the input or the context the LLM sees. So we kind of referenced the per field context. So each field gets a specific evidence that relates to it, not the whole document. So it takes a specific chunk of the document as the token. So especially for larger documents, this narrows the context and reduces noise. So you also want to feed any type of metadata around the document. So document and type, that can be as simple as including an extension in your files. Also kind of where the data originates, so the source, and then also any like page numbers or metadata associated with the document itself. Size, perhaps. So we kind of talked through ingest. Well, ingest is pretty self-explanatory. So we talked through classification. We talked a little bit about reg. So let's talk about chunking and embedding. So kind of at a 5,000 foot view, chunking is breaking documents into a smaller, reusable unit before anything gets embedded or searched. The chunking size is important, so small enough to stay focused and relevant, but large enough to preserve the meaning of the document. So oftentimes you can experiment with chunking sizes to see, how performance improves or decreases based on that particular chunking strategy. Overlapping, so basically you can use a technique called overlapping, so chunks share a bit of the context at the edges. So a fact split across the boundary isn't lost entirely in one chunk. So you can also experiment with, how much overlap how much overlap of the chunks you allow within your solution. Document awareness. So chunking boundaries, this is like your paragraphs, sections, table rows, rather than cutting an arbitrary character count. And then embedding. So embeddings, so each chunk is converted into a vector representation. That's your embedding. The embedding is capturing semantic meaning rather than just words. All right, so reg with pre-field evidence selection. So each field has to, extracts its own retrieval query against the embedded chunks. Retrieval returns the top n most relevant chunks. So this is how it's getting a similarity. This is what keeps the downstream prompt efficient and the results accurate. So instead of handing the LLM a 50-page document, hand it n chunks most likely to contain the value for that document. Field names, definitions, synonyms, all of these components within a configuration drive the retrieval query and its accuracy. So here's an example, a couple examples of document content. So we've got essentially page 2 and page 4 of a document. As you can see here, there's kind of a name, mailing address, and then some emails, right? And then page 4 contains kind of a claim duration, perhaps. So there's different types of data in each of these contents. So then this is an example of the output, right? So it would take both of these chunks and formulate it into this output here. You can see that it's already kind of extracting, some of the metadata. It's providing similarities, and then it's got like other metadata like the source. So this is just an illustrative example of what an output could look like. and that output is feeding the downstream steps for extraction. So prompt construction and field extraction. So this is the, what is it? Let's go back here. This is the last step here. So this is step 6. Oops. So for each field, the prompt combines the field definition, so what it is, expected type and format, the retrieved evidence, which is the chunks, and then any associated metadata, for instance, the source. So an example of that would be, given this field and this evidence, extract this one value. The output, like we saw in the previous slide, is structured, typically as a JSON payload, so that it can be essentially fed into a downstream system. And then when you're constructing your prompts, you want to do it in a way that's reusable. All right, so we kind of talked about chunking strategies. So why not just feed the whole document to an LLM? So we can kind of step through some of the advantages of breaking it into that kind of 6-step process. So precision, cost, context window limits, consistency, they all play a factor in kind of that following that 6-step process. So precision, it's more irrelevant context increases the chance of the model using the wrong section. Cost, so large documents produce long prompts, which are repeated by per extraction. Cost scale with document length. Context window limits, so very long documents may not fit into a model like ChatGPT, their context window, or Gemini, or whatever LLM you're using. Consistency, targeted retrieval per field produces more repeatable results. So one caveat here is context windows grow and models improve at document reasoning. This could potentially change. So you'll want to experiment with your chunking and your overlap sizes to pick kind of the right approach for your use case. So again, we kind of step through at a more detailed level each of these 6 steps. We should have a demo coming up here, I believe. Oh, okay. So we're going to talk about how do you set this up. So we have actually like a 2 jobs here. That's how we have ours set up. So the first just ingest the raw data. So let's say you put a like a PDF, for instance, you ingest that into the bronze layer of Databricks, and then after that, this could be your source data, could be Outlook emails, FileZip, API, something custom. Then you've got your raw data in bronze, and then kind of you start the 5-step process for extracting value out of that data. So it's the classify, parse, chunk and embed, retrieval, and extract steps. So configuration, you want to look at like connector settings, classification rules, field definitions, reg parameters. Having a 2-step process also allows for better auditability and logging. And then typically, and what you'll see in the demo here coming up, is that you'll want some kind of human in the loop. Because again, intelligent document processing isn't perfect. So that human in the loop is really critical to helping, one, the LLM improve its performance, but 2, also catching errors and being able to override any mistakes. And then having a monitoring dashboard is certainly helpful. And then, essentially the extracted output can feed into a various number of downstream sources, a warehouse for analytics. You can wrap it around an API. You can, feed it into a CRM or ERP, because like we mentioned, it's just a JSON payload that's pretty versatile. All right, so we're gonna skip these. We kind of talked about these. Let's go into the demo. All right. Oops. All right. So this is, let's see, is it visible up there? Yep, maybe a little bigger. How's that? Is that too big? No? Okay. So this is actually a Databricks app. So it's an app that's essentially a wrapper around those 6 steps. Actually, the 5 steps. There's a separate ingest pipeline. And then this is kind of a wrapper around those 5 processing steps. So this is actually the home page, actually. So this is kind of that that dashboard that we mentioned. So it'll load, hopefully. Maybe the cluster shut down. Yeah, I think the cluster did shut down. So in a few seconds, we'll see some documents here, and whether they failed processing, they weren't processed, they completed processing, or they're ready for that human in the loop review. So you can see most of them are completed here. But what we can do is we can go into one of these that's ready for QA review. So we can go in there. So this is kind of the output and the application around it. So this will load, and then you can kind of see all of, so this is an insurance claim document, first notice of loss. What you can see is that it kind of pulls what it expects these fields are, like branch type, right? It's saying it's main with a confidence level, 50%. That's kind of low. So that might be what the application allows us to do is reject these, approve them, update them. So maybe let's say, based on this document, right? So you can look at this document here. It's loading the document. You can say, oh yeah, I'm familiar with this document. I know it's, the branch type is main 2, right? And you can save the draft. Right, so it's a way to interact. It's a human in the loop. You can interact, update what the intelligent document processing step came back with. You can say, okay, well, the client claim number looks good. It's coming back with some high confidence. It looks right. Client company looks right. These all look, I can go through each one of these step by step, right, and review them. Or I can just, make sure there's no more red ones. Okay, the deductible's 1,000. Well, maybe let's check the document. 70 is kind of high, but also not, highly efficient. So maybe we can go in here. I don't know where I'll find it. We'll say it's wrong. How about that? We can add another 0 to the deductible, and then we can accept it. And then it'll actually use the updated output to help process future documents. So it's kind of that reinforcement aspect to it. So again, this is kind of a dashboard or portal kind of around those 5 steps around intelligent document processing. Now you see that, we did the QA review and it completed. So you can get, maybe I want to go and look at this last one, right? Or we'll pick a random one, right? So maybe it's completed, but I want to do a double check here. So this one's very simple. I'm actually going to, well, actually no extracted fields because this wasn't a claims related document. So, but what I can do is I can close this. You can kind of go through, you can go through every single document here. It just kind of organizes your output. You have a chance to correct any mistakes. And that's super helpful with, improving the document processor. So if you go behind the scenes, it's really this Databricks app. So it's a lightweight app hosted within Databricks that's kind of providing this UI. And then there's an ingestion step, right? So we mentioned that this dashboard is kind of a wrapper around those 5 steps. This is the ingest job. It's a pretty simple ingest job that copies data from a configuration file into the bronze layer. All right. Let's see. Let's go back to present mode. All right. All right, business impact. So why do organizations use this technology to extract unstructured data? Well, if you can imagine, there's a lot of important data and unstructured data. Think engineering drawings. Think some of the like the claims data that we saw, right? Some relational source data is actually incorrect, and the source of truth is actually that claims PDF, right? So maybe they want to fact check relational system with the source of truth, so they need to extract that data from the PDF and match it or do a human review to get more accurate source data. Accelerate decisions. This is just kind of more, you have both structured data and unstructured data at your fingertips. You can make, not just accelerated decisions, but also better business decisions. Data quality. So every extraction is auditable back to its source evidence. So as you can see, we, in that app, we could tell, we could pull up the source document, review it, trace it back to its origin. So it's helpful to have kind of an app around those steps as well for auditability and logging. Helps with versioning configurations as well. So if you want to tweak a configuration and see how that performs on a particular set of documents, that's very easy and doable with a config, like a metadata-driven, configuration-driven approach. Compounding value, so each new document type and data source is an addition to the platform, and it's not like a start from scratch type of initiative. So faster time to value, looking at how you extract unstructured data across an organization. In terms of what's next, the model improvement, you can always look at faster processing. Can you use like older techniques in the combination with LLMs and RAG? So can you use OCR and RAG together? Can you build a system that effectively uses both? Continuous learning. So we kind of saw that we gave the, with that interface, we gave some feedback. So we can now use that feedback to improve accuracy of the model. And then just going beyond kind of an application around the processing steps, we can look at agentic workflows and extracting, or beyond just extracting the data, taking further actions like routing or requesting information after that data has been extracted. So building it into an agentic workflow. Just one summary slide here to wrap up. So IDP is more than prompting. So as you see, it's basically a 6-step process, right? So there's a model, pipeline, and not just a single component. And essentially, um, I'd probably go beyond, that data engineering is a larger focus. It's really kind of the focus is now kind of tapping into a new source of data to drive business value. Um, you want to build for variability and volume. Um, Not only there'll be different. So think like the example we gave was insurance claims, right? Well, there's a whole bunch of forms, standard forms for insurance claims. So you want to be able to build a solution that can process all of those different types of claims effectively. And a big part of being able to do that is having a config-driven approach, which is actually the next takeaway. I didn't see that. Compounding value. So each new document type or data source is an addition to the platform. So you're not just starting from scratch. And then the last takeaway is that this is kind of just the starting point, right? You can kind of blend the app and the 6-step process into an agentic AI framework or workflow to automate decision making. So those are some of the takeaways. We can move on to the Q&A section. Any questions from the group? All right.
Do you have clients that you build the software for?
Yeah, so we have clients in healthcare, manufacturing, and insurance.
So then you sell them the software, or?
So we've got so I would split it into kind of two categories. We have products that we sell, like we have an intelligent document processor that can extract claims data, right? It's very specialized and niche. And then we have and then we build custom solutions. So if we don't have a product or a solution for that specific use case, we can build something custom. But kind of the idea behind building the solution config driven is that our one solution can extend broadly across industries and across use cases.
How do you give the software? Like if a company buys software, how do you give it to them? Like, it's not open book, right?
Yeah, so there's a cost associated with it. So the question for the online team is, um, you know, how do we, and I'm gonna paraphrase this, so correct me if I'm wrong here, but if it's a product, like what do we do, right? Well, we charge the client a subscription to use the software.
Oh, so they're just using the software. They're not taking it.
Yeah, so it'd be a SaaS application. But then when you look at the solutions that we do build, like those are the organization's solutions, their IP. So it's a little bit both. I was referring to the product side. Any other questions? All right, you guys are too easy on me today. Any questions online? Let me check online actually. I'm gonna stop sharing. Okay. Online, do we have any questions? I do not see any questions. So one, I'll make a little shout out here. There is a Wisconsin Databricks, we do have an official page. So if you guys aren't registered here, you can just Google Wisconsin Databricks user group. And it's actually the Milwaukee user group. So this is Databricks' official website. And then, so you can go, and then you'll get emails about future sessions. So you can join it from this link. It's just like one click, and then you fill out like your email address, your name, and then you're registered as part of the user group. And then you'll get roughly about 2 emails a month saying, hey, this is our next session, and then probably a follow-up like, hey, I hope you enjoyed the session, something like that, right? So it's pretty lightweight. Definitely encourage everyone to join the official user group page so you're kept up to date on our next sessions. But thank you everybody for joining. We've got a question from Avi back there.
Yeah. So I have one question. Like,
Yeah.
this document processing tool would have some obviously some cost involved with the company platform, all these resources. So why can't we just use a LLM to design a Java-based or Python-based tool to actually automate the extraction of those documents from the blog or any other construction format? This is the LLM to make changes to them to the tool.
Yeah. So I'm gonna paraphrase the question for the online audience. So basically, you're saying, you know, do you need to use Databricks to do intelligent document processing? Is that it? The question, or did I miss?
Yes.
Yeah. So I mean, Databricks is one tool. Snowflake has a capability. Microsoft has a capability. And then you can, like you mentioned, right? You can build something custom. Like you can, build, your own interface over an LLM. So basically, that's what we did in that demo, right? It's a Databricks app, but that app doesn't have to live inside Databricks. I think one of the advantages of using Databricks is that it is one of the higher performing um, capabilities in terms of document intelligent processing. It also has quite a few guardrails, so it's not only performant, but it's safe to use at an enterprise level. Cool. Any other questions? All right. Thanks everybody for joining, and we'll see you next month.